Good morning, everybody, and welcome to this tech update on the topic of hybrid cloud. My name is Morten. I am head of marketing at Netic, and I am joined today by Frederik Mogensen from Trifork, who is a cloud architect, and Claus Elby from Netic, also one of our cloud architects. So first of all, before we really get into stuff, I've got a few small points and some practicalities that we just need to get out of the way. So first of all, why are we here? Well, we're here because there is so much fast-paced progress and technological advancements in the world that as a business leader, it can be very hard to stay on top of them all. So as a tech company that has been involved in small and large technological projects in all manner of industries and verticals, Trifork has taken it upon ourselves to help you and to update you on the world of technology. Perhaps especially with a view towards let's say the applications part of technology. So that is why we have these tech updates that, because of the Corona world that we unfortunately find ourselves in right now, have to be virtual. Obviously, we hope to at some point be able to meet in the physical world again. So with that out of the way, just to set the stage, why hybrid cloud? Why do we talk about that? Why is that a topic? Hybrid cloud, at least from the experience of Trifork and of Netic, hybrid cloud is becoming the new normal. In quite a number of projects, we see hybrid cloud as a stepping stone towards true cloud native. But as you all know, we live in a world that is fast-paced and changing. And what was yesterday's stepping stone has, at least in many projects, become today's normal. So there are also other considerations. Maybe you are a company where data security matters a lot. Maybe you want to move your application to the cloud, but you analyze it and find that it is not ready to be moved to the cloud. So you take a partial step to the cloud and run your application in a hybrid environment. Whatever the reason, at Trifork and Netic, we see more and more projects that end up in a hybrid world, and given that, we wanted to take this opportunity to share some of our experiences with you, to how to then architect and how to govern your application or your applications in this hybrid environment. Now, why Trifork? Why Netic? Well, I guess most of you know Trifork. Trifork is, let's say, one of the leading software development companies in Denmark. So perhaps they don't need too much of an introduction. But Netic, well, why Netic? Perhaps there are a few more of you who have not heard of Netic, or at least are not familiar with what we do at Netic. Well, we are sort of the operations arm of the Trifork family. So what we do on a daily basis is that we help companies and public organizations with operating their complex applications, and we can do that from our own data centers in Aalborg, or we can do that in the cloud or in a hybrid setting. So Claus, if you wanted to move on to the practicalities slide. Thank you so much. As this says, just a few practical notes. We will be recording this tech update, so you will be able to receive it afterwards and view it at your pleasure. We have chat window in this Zoom platform. So if at any time during the presentations you have a question to ask, feel free to use the chat to enter your question, and we promise you that we will get to it at some point. Also, there is a post webinar survey that we will receive after the tech update. So we would really love to have your feedback to all that happens during this presentation afterwards. So with that said, I want to thank you all for attending. And without further ado, I'll hand over the presentation to Frederik and to Claus. Thank you.
Thank you, Morten. Hey guys, I am Frederik from Trifork, and this is Claus next to me from Netic.
Hi guys.
After the speakers, I would also like to say welcome and thanks for joining us today. The agenda today that we'll be going through looks a bit like this. So the learnings that we have here and that we try to present in this presentation comes from a project called the Food Project. We'll go a bit over what this is and why we chose hybrid cloud in this. We'll look at how to actually manage a hybrid cloud infrastructure so that it matches your hybrid cloud strategy. We'll look at what this means for the developers and what this means for all the people using your new hybrid cloud setup. After this, we'll go through a sort of conclusion, looking at what our main points are to gain a perfect hybrid cloud strategy, or at least one that actually succeeds. And then we end off by the Q&A that Morten just mentioned. So please put all your questions in the chat so we can have something to discuss afterwards. Yeah? Okay, so first off, the Food Project. What is it anyway? Well, Food is a national telemedicine platform where the goal is to help chronically ill patients to live at home instead of living at the hospital. So ill patients will measure their daily health and send in these measurements to the platform so that different doctors and different care personnel can see if you're okay. This platform is owned by all 5 regions in Denmark and all 98 municipalities. So it's covering the entire country. It's developed by Systematic and Trifork and Netic in a cooperation. And this platform will hold a lot of different applications trying to deal with different kinds of illnesses. So the first one will be COOL, or COPD, which is a lung disease. Then we'll have applications for complex pregnancies. We'll have applications for complex wounds. We'll have other different applications for chronically ill patients. And all of these applications are developed by a lot of different companies, not just by us. We only make the platform. This means that the entire setup here is not just a hybrid cloud setup, but also a multi-tenant setup. So there's a lot of focus on security, of course, because, well, e-health data, people's very personal data, and a lot of different people are able to look at these data through different applications. So there's a big focus on security and stability. So when I say hybrid cloud and that Food is a hybrid cloud setup, what does this mean? What we think about when we say hybrid cloud? And there's a lot of different definitions of hybrid cloud out there in the world. I specifically like this one from Red Hat, which says that a hybrid cloud is an IT architecture that incorporates some degree of workload portability, orchestration, and management across 2 or more environments. And when Red Hat talks about environments here, this is multiple public clouds or multiple private clouds, or public and private, or public and on-prem data center at your own site or whatever. So it's not production environment or test environment, but different cloud environments. And I'll try to highlight here the main things that I pulled from this definition, which is we have to have workload portability, so the workloads can run in different clouds. We have to have orchestration that manages stuff for us, so it's not manually doing all the stuff in the different clouds. And we have to have management, so all the clouds are managed by us by some sort of setup. These are the points we will look through in this presentation from different angles. Yeah.
All right. Thanks, Frederik. So when we are talking about private, public, or hybrid clouds, there are lots of things to consider. We pointed out a few that we found rather central to this. The first one I'll go into is regulatory requirements. So the public cloud gives you a lot of nice features, but you might have a data processing agreement that would require that the data should stay in Denmark, which would rule out some of the biggest public cloud providers. You might also have something in your data processing agreement that would require you to be able to do a physical data center audit, which doesn't really work in the public cloud world. And you could say, thank God for that. That would be a lot of people running in the data centers every day. So that could be one of the things that you definitely need to look into and help you choose if you should go private or public. Another thing that is worth looking into is the need for scalability and availability. The public cloud brings you unlimited capacity, but you might not need that. It might be that the application you're running is just for a number of users, or at least a static amount of users. On the other hand, you could have an application where you'd see exponential growth. Maybe you can't anticipate when it's going to grow, so you just need to be able to scale up really fast. And that's one of the reasons to choose a public cloud, because the private cloud tends to be a bit more static. Also, you could have a workload where you kind of want to scale across a classic two-center operations model that you know from most private clouds. So you could scale across different, more than 2 data centers, but even across different regions. And that also points to the next point about your customers or your users' proximity, where your users located. If all your users are in Denmark, it makes perfect sense to have a private cloud in Denmark. If your users are scattered around the world, you probably, depending on your application, want to have your application close to the users. And the public cloud would give you some great tools for that, because they have data centers, so-called regions, all over the world. So you can put your application where the users are. Flexibility is also a thing to look into. Being able to scale up and down fast is nice. You might have a workload where you only need to run it a few hours a day, at least with a high amount of traffic, so you can scale up to accommodate this. And you can scale down during the night because you don't want it. And that, again, is a direct influence on the cost. You only pay for what you use, the pay-as-you-go model. Of course, in a public cloud, you have the option to do some kind of commit to save money. If you know you have a baseline, you can run that for a long time and do a commitment on that, and that's definitely a way to save cost. On the other hand, if you go for a private cloud, you kind of know your costs, your budget for the long term. But then again, it depends on your application. The last thing we just pointed out here in this slide is the amount of managed services. The public cloud provides you with a lot of managed services, not just VMs that you can get in private clouds and public clouds, but also managed databases, managed queues, different storage systems, that lots of things. And that would, leveraging these managed services, would save you a lot of operational burden at a later time. But one thing that you should keep in mind is vendor login, because every public cloud provider have nice services, but think twice before just jumping into it, because you might end up being logged into that specific cloud provider because that service that you're using isn't available anywhere else. Of course, there are numerous of services that you can find everywhere. Managed databases is a good example, but at least when you look at relational databases like MySQL or Postgres. But if you go into some more specific databases and managed services, you might end up being locked to a specific cloud provider. So Why hybrid cloud? Because in food, as Frederick mentioned, we ended up with a hybrid cloud environment, and we're actually getting the best of both worlds. So for our production and pre-production environments, we run that in a private cloud, and doing this, we keep the data, the production data in Denmark. It is healthcare data, so we have to govern it. Well, there's a lot of security around it. We also maintain control and access to the entire infrastructure stack. And even though that you could use a public cloud for that and have it in data centers in Denmark, in Europe, there might still be some issues around how your support options are, because that could be following the sun. So you might have people from India doing support on your data, even though it's in Europe. So by keeping the production environment in Denmark, in Netix data centers, we ensure that the data stays there. On the other hand, we kind of wanted the flexibility and the things that the public cloud gave us in terms of development and test environment. So we could provision complete environments within very short time, which makes it easy for developing new infrastructure and platform services. So we do that in the public cloud initially, and once we're settled with that, we can implement that in the production environment as well. So that is kind of how we chose to do it in the food projects, getting the best of both worlds. And I think, Morten, right now we have a poll. So
we actually do, yeah.
So now it's up to you out there to do some work. Morten, can you pop it up?
Yeah, I think we should continue with the presentation for now. I ran into a technical difficulty, so
all right. Let's do that. Then we'll as soon as you have the poll, Morten, just say so, and we'll take it there. So I'll talk a bit about the infrastructure, building infrastructure in multiple clouds, what is needed there, and the considerations we have to make. So hybrid cloud governance, how to manage a hybrid cloud environment. I think there are two main points that I'd like to talk about today. The one is about defining common interfaces. If you have an application that you need to run in multiple clouds, on private and public clouds, you need to define some of the services you use. So go for open and standard services. Try to avoid logging yourself into a nice managed service at a cloud provider that you can't really do yourself in a private cloud. So for food specifically, it's built around Kubernetes. A lot of it, data persistency is in Postgres. There's a message queue using the MQP or OpenWire protocol. And that's kind of the basic layer of that, and that's portable. We can support that in every public cloud or in private clouds as well. In terms of using managed services in public cloud, using a managed Postgres is rather straightforward. It brings a lot of benefits. It's fast and easy. The thing specifically in food where we had some thought was about how to handle secrets. And Amazon, which is the public cloud we're using, have a secret manager, which is a nice place to store secrets for all these different applications we're using. But we can't really do that in our private cloud. So we actually opted to do to roll our own secret service. Oh, we didn't. We used Vault from HashiCorp. So, but we run a Vault cluster in the public cloud as well as in our private cloud. So from that, perspective, up the stack, you just have to talk to the same interface, which is when talking about secrets, which is the vault interface. So that's one of the things where you might have to build something self in your cloud, even though there is a managed service that you could use. The other part of this is your shared services. In Foot, we are running multiple production environments, we are running multiple test environments, and development environments as well, but they all need some shared infrastructure. IAM is one of them. You need to make sure how you can handle all your users. If a user is not working on the project anymore, you should just be able to disable or remove that user from a single place, and then all your systems should incorporate into this. You need repositories for your Git, for your source code. Since we are using Kubernetes, we have Docker images as well, pipelines. You need to define a logging and monitoring platform, or at least some interfaces, logs in containers on standard out, metrics are exposed in Prometheus format in this case, because then you can run it kind of everywhere. So how do we provision in the public cloud? We kind of want to make sure that all these environments are alike. So in public cloud, you could, or in private cloud as well, you could just go ahead and provision manually. That'll probably bring you a good piece or a long way really fast. But once you have to repeat it for the next environment, you probably run into some trouble because you can't remember how you actually did it and the order of things. So every cloud provides a solution to provision resources in there. You could opt for that. We actually opted for a third-party tool, Terraform. It could be Pulumi or Ansible for that matter. That would allow us to describe the infrastructure that we want to provision in the cloud. And I think, when you're talking Kubernetes as well, there are nice offerings in every public cloud. And we're seeing it as well in private clouds on Kubernetes. But you could instead opt to use something like Rancher or Anthos or even OpenShift and, run that across all the clouds, because then your Kubernetes environment would be exactly the same across your different environments. But I think the key takeaway here is to make sure that you have your infrastructure as code. That is definitely important. All right, Frederick.
Yes.
Developing.
Yes. Okay. So now we heard Claus explain a bit about how to manage these different hybrid clouds, these different clouds that we want to set up. And which services to consider putting into them, and which services to have as a shared service between all the clouds, or across all the clouds. And I'll try to talk a bit about how we can make this work for the developers. So when we want to make a hybrid cloud setup and a hybrid cloud strategy, how do we make sure that the developers can leverage all the possibilities and are not slowed down by this hybrid cloud? We want them to move faster because of the hybrid cloud, right? So first off, how do we, as a developer, build and run applications in the clouds and across all the clouds? Well, as Claude mentioned before, one of the key takeaways here is to make sure that all the clouds, private and public, behave the same, so that they have the same interface everywhere. This could be running my applications in Docker on Kubernetes. This is very standardized setup for running the application. Talking to a specific Postgres database, for example, and talking to a specific message queue, whatever you have needs, as long as these interfaces can be put into every single cloud. In Foot, we use Docker with Kubernetes, we use Postgres, we use ActiveMQ, and Amazon, we actually use the managed version called AMQ, which is basically the same thing. And we can deploy all of these to all of our different clouds using Helm charts. So whenever a developer comes in and says, I have this application that I want to run across any of the clouds, he will use the Helm chart that we give to define which application to be running and how to configure it. And this can just be thrown at any cloud in any of our environments, and it will run the same everywhere. So not just running the same code and the same config in all of the clouds, but actually also running it on the developer's laptop if you want that. Because all of these tools and all of these interfaces can also be spun up easily on a laptop. So we have the same environment, the same interfaces all the way from the laptop to public clouds to private clouds, which makes it super easy for the developer to understand how the application is running and what to talk to. If we look at a nice graphics for this, we see the application layer at the top. This is where all my business logic lives. This is what actually makes the money, right? The nice thing about the setup I just described with using Docker and Kubernetes and these centralized common interfaces is that you can actually implement your business logic in whatever of these languages that you want. You can easily have an application written in Go or in Java or in .NET and talk to the exactly same interfaces because they are all standardized. So the developers can choose the tool that works best, or you as business units can choose the tools that you want to support in your entire organization. Then we have the common interface, and we have a platform layer, which is the layer that the applications interact with. So the Kubernetes part, the Postgres parts, the databases or queues or whatever you have. And these will be running on top of some sort of infrastructure. And the infrastructure in this graphic is any of the public clouds or private clouds. And using this layered model, we can easily abstract away everything that makes the different clouds different. So that it's easy for our applications to behave the same. Okay, so I have defined how my code is actually running and what makes it able to run on the different clouds. The next question is, of course, how do I actually push the code into the cloud? How do I install it on everything? And this is the part of the managed thing that Red Hat talked about, and also a part of the orchestration thing that Red Hat talked about. Those two keywords in the definition. So what we propose is to say, again, the same as in the infrastructure layer, define everything as code, as configuration. If you define how you want your application to be running and what configuration you want them to run with in code, you can easily take that and apply that to every single cloud. Especially if you use, for example, one of these deployment frameworks. These deployment frameworks we see down here, Argo and Flux or Jenkins or Jenkins just, all have that very nice property that they run on top of Kubernetes. So on top of this common interface that we already defined, it will be across all of our different clouds. So we already have cut away everything that makes the clouds difficult to handle because we have a common interface. If we then define our applications in code and give the code to these applications, to these frameworks, they will make sure that the code and the applications are running in every cloud exactly the way that we specified it. So that's a very nice way to do this, and a very nice way to orchestrate all your code across all your clouds. In Food Project, we use a Jenkins setup, which installs it in all the different clouds. Going forward, I would recommend using one of these new, very nice frameworks, such as Argo or Flux. They really have a lot of traction at the moment. Okay, so I can install my code into the cloud and run it across all my clouds. The last thing is, well, how to make sure that it keeps running, right? How do I monitor my code? How do I make sure that operations know what's actually happening? Again, this is, I won't say it's easy, but it's simple because it builds on the same principles as all the other things we just talked about. It's a question about saying, well, we have a predefined shared interface for how we do logging and how we do metrics, how we do secrets. And if we have this predefined shared interface, then it's easy for developers to write an application and make sure that the application can be monitored afterwards. What we do is we say all logs will just be printed out by the application, and we have infrastructure that will pick up the logs and send them to our log aggregation service. All the applications will also provide a metrics endpoint where you can see how much CPU the application is using, how much RAM it's using, how much network it's using, if it has any problems and stuff like that. And these two standards here are actually very well-known standards. These are used in a lot of applications, not just our specific applications, but a lot of the shelf software that you can pick out, standard software can figure out. Which means that all of the standard software can also interact with your entire environment, entire infrastructure in the exact same way. If we take a look at an example, this is an example from food. We see here on the left, we have 3 different environments. We have a test environment, we have a pre-production environment, we have a production environment. We see the test environment runs in AWS, by the small icon in the corner. We see production runs only in the private cloud, and pre-production could be running anywhere in this example. We see all the environments have the same shared interface, no matter where they run, with the Kubernetes and the database and the queue. And then we have the shared infrastructure, the shared environment that Klaus talked about. This is where the users and permissions and IAM runs. This is also where our log collection and our metrics runs. This means that if you create an application for this platform, for this hybrid cloud setup, and no matter which environment you throw it on, if it logs and if it says metrics in the following the standard environment, the standard infrastructure that we defined, they will all run to the shared environment and they will all be accessible in the same pane of glass. So you will have one central place to look into how all the different environments are running and see if there's any problems on them. See if there's any, see if there's any problems. See if you're running out of memory and see if you have an application that crashes on all environments or just on that specific environment. Yes. So this is a bit about, from the developer's point of view, how to do all the stuff and which demands that push on the hybrid cloud and the hybrid cloud strategy.
All right. So Morten, do you think we have?
Yes, we actually do now have the poll question. So I'll launch the poll now. The poll will be anonymous, so so we won't be sharing any of your business concerns with the rest of the audience. So we'll just take a minute to collect the answers. And in the meantime, Klaus, I think we should start with the first question. So we have a question that has come in where a person wants to know what is the easiest workload to move to a hybrid cloud?
That is a good question. The easiest workload to move to a hybrid cloud. I think as we discussed, it is something that you would be able to run both in the public cloud or in the private cloud. So even you could go for a workload running on a virtual server because you can run virtual servers in your public cloud or in your private cloud. But again, if the interface that this workload kind of provides is available as a managed service, then that would be a nice addition, to remove some of the operational burdens on that one, so you could run that in the public cloud. I think one of the things we haven't talked much about is the stuff where you scale from your on-premise cloud or private cloud to the public cloud, so you can kind of absorb bursts. I think we don't do that in the food context. That's mainly due to that we want the things to stay in Denmark, at least for the production environments. But for other solutions, that could be a way to do it.
Yeah.
Okay.
If you want to have a true hybrid cloud environment where you have the same workload running on multiple different clouds, then I think the easiest workload to start doing that with would be a workload that is stateless, that doesn't have a database, for example. If you have a workload that does just some processing or that just answers a question based on rules, for example, that would be super easy to spin that up in multiple different clouds, so that no matter which cloud you ask, which instance of the workload you ask, it will always answer the same thing without having to consider spinning up a database and synchronizing databases across clouds or spinning up message queues that can push messages across everything. So a workload that has the least amount of services that it needs to rely on, I would say would be a great choice for an easy workload to move.
Yeah.
So before your conclusion, Frederik and Klaus, I'll just read out the answers to the poll. We've got 16% saying AWS, and I apologize for not making the poll multiple select. 11% for Google Cloud, 47% for Microsoft Azure, perhaps not surprising in Denmark. 5% other public clouds, 11% private cloud, and 11% private on-prem data center. So Frederik and Klaus, before we move on to the other questions, any concluding remarks?
Yeah, let's just jump into that one. Sorry. We kind of just try to summarize what we've been through. A hybrid cloud recipe, or maybe the hybrid cloud recipe, is kind of up to you to decide. It worked for us, but I think the important part is to identify your needs and requirements. The regulatory requirements might be what allows you to put something or everything in a public cloud, but it might also be, on the other hand, what would make you do a hybrid cloud strategy like we do in Food, where we have test and development in public cloud and production environment in private cloud. The same for scalability, what you need, what is you need for the flexibility, also in terms of cost. Managed services is definitely also something to take into consideration. And then again, as we mentioned a number of times, choose these common interfaces. Kubernetes today seems like a really good fit between, where you on one side have a classic VM, which is kind of heavy to move around, and if you go far along to the other side, you will have functions as a service like AWS Lambda and stuff like that, which kind of tends to be proprietary. So Kubernetes sits in a really nice spot between these, and I think in the future we will probably see even more workloads running on Kubernetes. Today, stateful stuff, the Kubernetes persistent layer is still rather new. Well, there are lots of different offerings, and they all behave a little bit differently, everybody, all of them. But we'll definitely see some traction in that one. So within a few years, you'll probably see everything running in Kubernetes. And then I think the most important part as well is make sure that everything is as code. Your infrastructure, your platform, your applications, your configuration, everything should be as code. That is a must. And of course, you need to educate your people. Make sure your operations teams or site reliability engineering teams knows about these new toolings. The same goes for your security staff. They also need to embrace this and understand the complications or maybe the benefits of running things in public cloud or on hybrid cloud. Of course, your developers, they need to be able to use these things, and I think they'll probably be glad because now they can say it runs on my laptop, and you can say yeah, and it runs in production. So that is really nice. So yeah, I think that was kind of the conclusions. So more questions, or did we have a poll more?
So I think we should move to the questions. So we have one question from Ellen. How do you handle the fact that logging, for instance, Humio, is a cloud-based system? What about metrics? Are those in your private cloud?
Could you repeat the question? I didn't think the.
Yeah, I think that the question alludes to the fact that your logging system can be a cloud-based system. There's Humio Cloud, and you can have Splunk Cloud and other logging systems.
Yes.
So what about your metrics? Can you then have those in your private cloud, or how do you handle that?
Okay, so if you should take the foot hat on first off and say what we did there, we choose to have actually two different shared environments. So we have one shared environment that runs in the public cloud for all of the different test and education and development environments we have there, and we have one running in our private cloud for our production environments. And this is mainly because of the regulatory requirements saying data can never leave Denmark. So we didn't want to push all of the logs to some sort of cloud-based logging service because, well, I won't guarantee that data never enters the log in any sort of way. So we run that in Denmark to get these very easily guarantees. On the other hand, it can be quite costly to move every single log and every single metrics from the different public clouds into a data center running in Aalborg. So that's why we chose to have two different setups that are the same setup. It's completely same setup, same log service running both places, same metric services running both places. And what we actually chose to do in Food is we are running in Splunk, and Splunk allows for both ingesting logs and metrics. So we have all that in the same application as well. You could easily choose a hosted Splunk or a hosted Humio and put both the logs and metrics into those. That's also a very valid option.
And I think to add to that, we of course, in public cloud, when we use the managed services up there, like the PaaS services, some of the logs from there and the metrics from there goes to the cloud providers monitoring solution. So it will end up there because you can't install any agents on a managed database, at least not on the servers running the database. But we can get the info, the metrics and the logs from these from the cloud providers platform, just to have it all aggregated in one single solution. Yeah.
Okay, so so we have another question, which is about tooling for multi-cloud cost monitoring. So which tool is best used for multi-cloud cost transparency?
I think one of the, since we are not if we take the foot hat on again, we're not multi-cloud. It's a hybrid cloud, but every cloud provider have their own cost tool. But this is a question about multi-cloud, and there are some third-party tools. One of the tools that we are looking into is a tool from VMware, which is called Cloud Health, which will give you a really nice view into, it aggregate all the data from different cloud providers and give you a way to slice and dice and do drill downs in your cost. It requires you to do some tagging. The better tagging you can do, the better drill downs you can do. Of course, it would do it on whatever metadata is already available there. But doing some tagging would definitely help you do that. So that is one of the tools we're looking into, besides what the cloud providers have themselves.
Yes, there's also a couple of different tools which are free and open source for looking at just workloads in Kubernetes. So if you use Kubernetes as your runtime in all different clouds, you can go in and say, well, this bunch of applications are run by this team, and then how much money are they using across all of our different clouds, which is kind of nice.
Okay, thank you. So I want to thank you all for joining today. I think we're right on time. So so Frederik and Claus, thank you so much for taking your time to presenting this, and to all our viewers. Thank you very much. If you have any further questions, you can direct them at Claus or at Frederik, whose email addresses will be communicated to you in the post processing of this tech update. So thank you all for joining, and have a fantastic rest of the day.